Hello. For this design challenge, each team was asked to generate an idea about a most beautiful machine and present that idea to another team, otherwise known as the design team. The design team was then asked to create a conceptual design and initial prototype based off the client team's description of the desired most beautiful machine. This PowerPoint shows how Team 38 went about creating a conceptual design and prototype that met the client team's specifications. The client team left the design of the model up for interpretation for the most part, other than describing the model as a system where you put an object down and it is returned to you in the same direction. The only other notable detail was that the client team stated the system should reset automatically.
In order to categorize whether or not we had a successful project, we needed to lay out our metrics, and in order to do this, we asked follow-up questions. Our first question was, does the machine have a target size or shape? And our response was, no, but it must be big enough to launch a projectile. So naturally, our follow-up question was, what is the size or mass of the projectile comparable to? And it was compared to a small stress ball of approximate diameter of 2 inches. Finally, our last follow-up question was how far does the projectile need to be launched? And for that, our response was there's no set distance and that it was up to the engineers to determine how far the projectile could be launched. With our follow-up questions asked, we felt comfortable laying out the metrics for the project ahead of time in order to categorize whether or not our prototype had been a success. Our customer needs included having a device that launched a projectile the way it came, having a device that doesn't drop the object during launch off the side, a device that was ready to relaunch a projectile upon the retrieval, and finally, a machine that could launch a projectile of various size. Our technical requirements for this was it could launch 3 times in a row, shooting it the way it came without it falling off the sides. And our next technical requirement was that it takes 5 seconds for the machine to get ready, which would allow for adequate time to reload and retrieve the projectile. And finally, we decided, based on what was specified in our follow-up questions, was that the machine should be able to launch a small stress ball of approximate diameter 2 inches. With our metrics laid out, we felt comfortable designing the rest of the prototype.
And now to show the systems diagram for the final design for the client. To operate this model, the object will be placed at the top of a ramp before being rolled down and hitting the touch sensor placed at the bottom. The touch sensor signals to the motor to begin running, and this motor is connected to an arm that will hit the object back up in the same direction as it rolled down the ramp. This series of actions meets the client's team's design specifications while using all 3 systems, the control system, the loading system, and the launch system, in conjunction with each other. Power was applied to the control system, which powers the entire model in tangent with other inputs to make the model work to its intended usage. And now for an analysis of alternative prototypes that were not ultimately used in the final design. There was a prototype considered that laid on the ground, but it was pretty unstable and inconsistently returned the ball. So it would have only worked for specific placements of the object and was too specific for the broad design specifications given by the client. Also, an ultrasonic sensor was also considered instead of a touch sensor at the bottom of the ramp for our final design, but through previous experiences, this was decided to be too inconsistent and a tactical sensor was utilized instead.
Following the conclusion of the aspect of the engineering process that involves assembling the machine and generating the software required to function properly, the engineers of Team 38 exposed the machine to numerous tests. These tests involved a 2-inch Lego wheel rim being rolled along the ramp towards the touch sensor and being launched in the opposite direction along the ramp as soon as the touch sensor registered the projectile and caused the motor to rotate an extended rod about its central axis, which would strike the projectile with enough force to launch it. The engineers of Team 38 repeated this process for a total of 5 tests and were pleased to note that, as depicted in the video, the machine operated successfully during all of these tests. Additionally, the engineers of Team 38 were pleased to note that, as depicted in the video, the average reset time for the machine fluctuated at about 1 second, and the projectile never exceeded the bounds of the structure. The only difficulty experienced during this testing process was that rotating the extended rod at high speeds about the central axis of the motor would cause the pin holding the structure together to become disconnected and require repeated assembly. To improve the structure of the machine for future iterations, further structural reinforcements would be applied to the connection between the extended rod and the motor in order to increase the durability of this machine. Additionally, to improve the software required to operate this machine for future iterations, the speed at which the motor rotates would be further tuned to an optimized value. Thank you for listening to Team 38's pitch. Our engineers hope you were pleased with the machine and its results.